Hey guys, today we're going to be looking at powers of products and quotients. Our essential questions are right there. We're going to be looking at how exponents distribute to multiplication and how exponents distribute to division. All right, for this one, we're going to be looking at the powers of products rule. And to expand it out, we're going to actually write out our 3a to the fourth power here. So we're writing it 4 times. And because of commutative property, it's all multiplication, so we can move things around. And so we actually get 3 to the fourth, a to the fourth, which 3 to the fourth is 81, and then a to the fourth just tags along. Then for our next one, we have the quantity of negative 4n to the fifth, all to the third power. And so for this one, we have our negative 4n to the fifth, and then we have that 3 times. And then that ends up to be negative 4 to the third power times n to the fifth power to the third power, which then negative 4 to the third power, that's negative 64. And then n to the fifth power all raised to the third power, we're going to use our power of a power rule, and that's going to be n to the 15th power. All right, I want you to hit pause and try out the next 2 without me to see if you get the correct answer. All right, so let's check your answers to these last 2 here. So for this one, we expanded out 3y squared, and we did that 3 times since it was to the power of 3. And then looking at this, we had ended up with 3 cubed and then y squared cubed. The 3 cubed became 27, and then the y squared to the third power became y to the sixth power. For the next one, you ended up with a squared to the third power, b cubed to the third power, and then c to the fourth power raised to the third power. And for that one, using our power of a power rule, we ended up with a to the sixth times b to the ninth, c to the 12th power. So the rule for this one, hopefully you kind of see how it's emerging here, is a times b to the nth power equals a to the nth power, b to the nth power. Now there's a little clarification about this rule because we know that exponents are really repeated multiplication. So an exponent can be distributed to multiplication. However, you cannot distribute an exponent to addition. For example, if we had 3 plus x cubed, that does not equal 3 cubed plus x cubed. We're going to be looking at that later on in the year. However, I just want to make sure that you know that this only works when you have multiplied bases. So we have bases here that are multiplied by each other, and we don't have addition inside that parentheses. All right, next we're going to be looking at powers of quotients and how that rule applies. For our first one here, we have 3/4 to the third power. So hit pause and write these 4 examples down, and then let's expand and simplify the first 2 together. So for the first one, you have 3/4 to the third power, which is the same thing as 3/4 times 3/4 times 3/4. And since we have multiplication, we really don't need that parentheses right there. But when we're multiplying fractions, remember we just simply multiply numerators across and then denominators across. So 3 times 3 times 3 is really 3 cubed, and then our denominator would be 4 cubed. And so to simplify this one, it would end up to be 27 over 64. For the next one, we have a over b squared all to the fourth power. So this one is going to be a over b squared times a over b squared, and we're going to repeat this 4 times since it's to the fourth power. And then we're going to multiply our numerators together, and that would end up to be a to the fourth power, fourth, and then b to the second power raised, my second kind of got wonky there, second power raised to the fourth power, and that would equal a to the fourth power, and then using our power of a power rule, this would be b, doesn't want me to write today, b to the 8th power. So hit pause and see if you get the correct answers for the next 2. Try those without my help. All right, here's your answers for those last 2. We had t squared over 5 all to raise to the third power. Hopefully you could tell that that was a 3. And for that one, we ended up with t to the 6th power over 125, because 5 to the third power is 125. For the last one there, we had w to the third power over -2, all to the fourth power, and then we took that fourth power and applied it to both our numerator and denominator, and we ended up with w to the 12th power over 16. Our rule for this one, hopefully you figured it out, is a over b to the nth power equals a to the nth power over b to the nth power when b does not equal 0. So there's a rule again, a over b to the nth power is a to the nth power over b to the nth power. An exponent can be distributed to division because an exponent is repeated multiplication and they're related. However, an exponent cannot be distributed to subtraction. So for example, 3 minus x squared does not equal 3 squared minus x squared. So I just want to make sure you know that it has to be with division or multiplication in order to use the 2 powers rules that we applied today. All right, find a corner of your paper and I want you to jot down this one problem and take a second to solve it without my help. So hit pause and solve this one without me. All right, checking to see our work here. The first step I did is I took this third power and then I applied it to both our a and our b, our numerator and our denominator, and then took each of these factors inside and then applied that cubed to them and ended up with 125n to the 12th, z to the 18th, all over the quantity of 8 times x to the 24th, z to the 9th. And then we can take this and simplify even further. 125 over 8 we can't simplify, so I'm going to write that down, 125 and then my 8. And then I look at this and I only have n's in my numerator, so I know those have to stay, n to the 12th. And then my x's are only in my denominator, so I'm going to write those down, x to the 24th. I have z's in both my numerator and my denominator, and so then those I can simplify to z to the 9th. And there's the answer.